another fantastic speaker who embodies the spirit of redefined possibles throughout career transformation. I'm delighted to introduce Lakshmithejaswi. Lakshmi will be sharing her journey with us in a presentation titled Unlock Your AI Potential Guide to Building a Machine Learning Career. It's truly inspiring to see individuals embrace new challenges and navigate the exciting world of AI. Lakshmi's talk will outline her own career transition into the machine learning space, offering invaluable experience and helpful resources to empower all of you. Whether you're a developer, automation engineer, or simply a tech enthusiast, to embark on your own AI adventure. She'll be uncovering the various strategies and resources she used to transition from Oracle development and automation engineering into the dynamic field of machine learning. Get ready to unlock your own potential. Please give a warm welcome to Lakshmi Jasvi. Okay, I'll stop sharing.
Great.
And
I'll go
you
ahead
are
and share.
welcome. You can share your screen.
Yeah. Um, okay. Let me know if you're able to see.
Everything is perfect.
Okay, sounds good. So thank you so much for giving me this opportunity, and for a warm welcome. And I also wish everyone happy International Women's Day. And I would like to thank everyone, all the women in my life who have given me opportunity to, in personal life and also in career to excel and keep growing. And I would like to also take this opportunity to remember my mother who have played a great foundation in my entire life to keep going forward in both ups and downs. And without any further delay, we can get started. Today, we're going to talk about my journey, my career journey, and also resources for anyone who wants to step into machine learning world. Right? Great. You can see I have a pretty long name, Lakshmithejaswi and Narasannagari, so feel free to call me as Lakshmi. And ML and automation is my expertise. I love to grow plants and produce food. The pictures on the right side are my pictures from my garden from last spring and summer. So I'm excited for this year, spring and summer too. I'm a big fan of my two sweet little kiddos and my husband Vijay. Um, also an author of a book chapter which talks about uniting AI and healthcare for precision outcomes, where I dive into how different machine learning algorithms can be applied to get the personalized medicine in healthcare industry. And the next article was about building observable machine learning systems, where I deep dive into um, uh, how to build a model and also how to have that mindset of observability from the start to at the when the model goes live too. So it's a pretty interesting read and also a long one. If anybody is up for a bedtime story, I strongly encourage you to read, but it's not a bedtime story. Yeah. These are the pictures that I will show for the last time. I will no more longer bore you all with my garden pictures. But the reason I'm showing this is you see from the left side, the plants are baby plants, and you see on the right side they have grown, matured, and they're producing food, right? And I want to put a perspective even in life, take this as a career transition journey. We all start small, but we keep building. Though there are the landscape is changing of the job market. There are a lot of uncertainty times the tech industry is going through. Just like how these plants go through different temperatures, weather changes, and they take a lot of soil amendments to keep growing. So a lot of care. So I think the same applies even in our career journeys, like, keep growing, keep that open mind. Um, Use lots of tools and resources to keep growing in your career, and I'm pretty sure you'll see the benefits out of it. Yeah, I just wanted to put that perspective here as a analogy, and I love to talk about plans. So yeah, moving on. This is my career journey. I've started as an Oracle developer in 2011, where I worked on building uh, Python scripts to move data migration from legacy systems for Orange customers, like building scripts and testing scripts to move the large databases. And there, I worked there as a Oracle developer and then moved into automation engineering, where I got a lot of exposure going into a startup. So from backend to front end, so I kind of started working on web application testing and mobile application testing, where I built a lot of frameworks. And also, I remember, like, I'm the only woman in the startup at that time in 2013. All men, just one single woman. And I kind of, when I initially joined, this is something different, but I got a lot of exposure to work on wear different hats in my job, and I've kind of built the QA and automation team from scratch. So developed a lot of leadership skills in that time frame, and I got an opportunity, and I moved to US and transitioned, continued to do the automation and also testing. And in 2019, my manager believed in me, and I started working for data science applications. I think I initially got hired for automating web application features to automate the workflows, but all these web applications were powered by AI behind the scenes, and I kind of understood it's not a very straightforward way to automate the features that are powered by AI. So I had to um, level up my skill set. Then did a lot of learning, experimentation to work on data science applications, where I also built observability frameworks from scratch. And I will dive into what I have done during this phase in a moment. And there, that gave me a very good foundation, and also gave an opportunity to pivot my career from automation engineer to um, the staff software engineer into machine learning. And I started working on deploying and monitoring models, building ML architectures, migrating models into cloud systems. So, and I'm still continuing to do that. I'm also stepping into research a little bit these days for writing, but that's a long way to go. Yeah, yeah. So I think the landscape is changing a lot for anyone who is, wanting to get into this space. I think there are a lot of job titles, and it's so possible to get confused which is doing what. And I think this is really important to understand what is a machine learning engineer, what is an AI engineer, right? I'll try to break it down, but there's a lot of overlap, and that is the reason I'm trying to keep things clear here. An AI engineer, you will see that AI engineer works for in various industries for the application to work. For example, healthcare, email marketing, and lots of different things, right? And they build the models. They make sure the models work for different industries and applications. They have the holistic view of model building to until the model goes live into different. And ML engineer is also very similar, but ML engineer has a very deep expertise into training the model, making sure, optimizing the model for the performance of applications, and also monitoring the model throughout the entire journey from build to end. So that is the main difference. AI engineer has a big umbrella, and ML engineering is part of it. I think that's really important to remember for anyone who wants to step into. Okay, in a nutshell, today we are going to focus on ML engineering because that is my expertise and I would love to talk about it, what I have done. In a nutshell, I think it's really important what's an ML life cycle is. It has two phases, like, ML application building, platform building, and also having ops mindset to it. But when you get the ML engineering ops mindset to it, it's all about ML lifecycle, right? It is the continuous loop of deployment, monitoring, and refinement of your models. Um, Imagine automating everything is the basic mindset. Um, if you put the same thing into a picturized, this is how it's going to look. And the picture is from sourced from Machine Learning Mastery, which is like a favorite resource to anyone who wants to build the basics of their machine learning career. So, in a nutshell, you're kind of automating the model building and also letting the model take the inputs and outputs from the inference, and also have the mindset of scaling the application, right, using Dockers or Kubernetes and things like that. So it has three phases, like building, inference, and scaling. And scaling, there's a lot of other things that happen after taking the model live, but in a nutshell, this is the main core of the application is. um, and it's more about bringing, personally, at least in my experience, it's more about bringing DevOps principles into ML, as like, machine learning engineering, right? Automate every single step of the way for the model to actually see the take the live predictions from the applications. Is about, like, every step of the way: model training, model building, and also model monitoring, right? Build and run it, build and run it, build and run it, and you copy that same thing, but it varies a lot. It's just not very straightforward. Build and run it and monitor everything. When I say monitor everything, uh, this is about, um, the landscape is so different. There are tons and tons of tools that are available to monitor your models and applications, but it is the crux of it. What is the transition? How is this model learning, and what are the inputs? What are the outputs? How are the inputs changing? How are the outputs changing for every time and for each build? So, what is the performance of the application that is on live? Is it really performing the same way when the model is deployed like a month ago? Is there anything change in the context of the application? So you kind of keep a tab on each and everything. That's the whole, like, machine learning is, I believe. Yeah, and ML testing is something very different from traditional testing, and this is where I kind of understood that. Imagine in traditional testing world, the application actual values and the expected outputs. So it's easy to put automation around it. Okay, this is my expectation. So you either generate the values dynamically, and then this is the actual output. So you put a check over there using different tools, right? But ML testing is not very straightforward. You have a lot of room to um, uh, actually be very creative. I would say in the space, it's really important to have that edge in thinking, cause the model outputs very differently. For example, if you take any large language model, Gemini, AI Studio, AI, or, like, for example, ChatGPT, you ask a question, same question repeatedly, like, 10 different times, the outputs keeps changing. Even if you ask, like, what is the weather today, there is a variance in the output. So the, it's not very straightforward to put this is the model should give only this output, right? It's not that. There should be an emphasis on variations, like, thresholds. How is this model behaving? What is the accuracy? So there are a lot of different concepts that one has to learn if they are stepping into ML testing, and I see that for anyone coming in from non-technical background, I think this is the space that they can be a little more creative, because people coming in from non-technical background, they have a, I see that they are very strong in overall application behavior. Like for example, QA engineers, automation engineers, or product engineers, like or technical program managers, like, they have the holistic, very, very strong in the overall application flow, and like, how the model, how the applications are behaving out wild, and what the customer is seeking. So bringing that mindset into ML testing is really important, and there is a lot of leverage in terms of um, how you're building test cases. Like for example, unit and integration testing is not also very straightforward. Have to tune in and apply, thinking of like, how do you test data, how do you perform analysis, EDA analysis, and what type of metrics that you want to track on the data. um, and um, and how I have done it is like, test every step of the way that I'm working on the model that I'm trying to deploy, right? For example, pre-commit hooks, follow the data everywhere, like I said in the beginning, from inputs and outputs, like, what is the transition, data profiling. So there's a lot of variations that one can do in ML testing space. And I see that this is an entry point, and I also see a lot of jobs recently have transitioned the testing roles into ML testing. They are now seeking um, engineers who can test NLP based models, who can, like, build prompt engineering techniques, in terms of automation. So there's a lot of creativity that is happening in ML testing space. Yeah. So this is my solid background roadmap that I would suggest to anyone who wants to get into ML. There's no straightforward way and no one solution for everyone, but I see that having this as the foundation will help you succeed. One has to get their hands dirty and start coding in Python. Uh, and I also see a lot of applications getting models getting built on R, but I at least for me, Python is the most easier stepping stone for me. So I've learned Python myself, and I started working on building small programming while I'm working on, for example, in terms of ML testing, you can use PyTest to test data science applications, right? So it's the basic language. You just need to get it. You don't have to be very, very deep expertise in writing Python code, but at least like you should be able to um, run the basic programmings, like, build small functions, helper libraries. You should be comfortable using the libraries, the frameworks around Python, the libraries around Python, right? Yeah, PyTest is the very good, easier way to understand how to start programming. Yeah. And the next step I would say is getting comfortable around ML tools and ML frameworks like Pandas, Keras, and Scikit frameworks. There are really tons and tons of tutorials on Google to how to use pandas, how to use Keras, and they're like very, very simple models that you can build on Keras and Scikit frameworks. Um, Really understanding what are these model types, for example, classification. What is classification? What is regression, right? Um, I think it's really important to uh, understand how a classification model works. Like, how is this model even thinking about classifying an image, whether it's a cat or a dog or something, or a human face, right? For example, you ask a model to generate a model. How is this, why is this model generating only men face? Why is this model generating only women face? So you just have to critique everything and understand all these model types. You don't really have to get into the deep dives of all these algorithms, but still the basic knowledge is necessary to work with ML modeling. Um, yeah, at least like supervision versus supervised versus unsupervised, and regression, classification, wave Nayars. There are a lot of terminologies, but I think just like once you get into this momentum of learning ML tools and frameworks, the landscape is huge. It's like a big ocean. But yeah, and I'll another tip is like, once you get comfortable with ML language, um, you bring that DevOps principles into your work, right? That is really the core of ML engineering, I would say, like, the ML ops world. Bring that CI/CD, understand CI/CD pipelines where you build the model, deploy the model, monitor the model, like that phase kicks in. So get comfortable creating the projects on GitHub repository, get comfortable using GitHub Actions, what they do, GitLab. These are really great resources, and they're open, like open to use with free trials and things like that. Jenkins is also one very good tool to understand the CI/CD pipelines. And I know many people are transitioning from SRE roles into DevOps world. I think they can use the existing tools to transition into DevOps, from DevOps to MLOps, right? And once you get comfortable with GitHub and Jenkins pipelines, the next step is to think about how do you scale that application using Docker containers, Kubernetes. How does this work? How do you incorporate scaling your application through the code, building these YAML files, or like cron jobs and things like that. And really, really important to have that mindset of making everything cloud based, right? You don't want your model application to be localized and no one can see your application. That's really so. And I'll share that GCP is a really great resource. It has like 90-day trial version for 3 months. So it's a great resource. It has tons of all ML platforms that you can leverage to, play around with, for example, Vertex AI pipelines and cloud storages to store your data and transition your model inputs and outputs. So it's a great resource. I always recommend to check out. GCP is really good 90-day trial. And once the ops automation and cloud mindset is done, now it is really important to understand how do you monitor everything, right? Tools like Airflow, scheduling your model training pipelines and model building pipelines. Airflow is the best, and there's also an ML flow that you can use, but I would use that for later. But Airflow, most of the companies do use. Grafana and Prometheus are also like, you just have to, I don't say that you need to get into everything to start your career, but at least like understand how these work and how they are useful in your ML application building, right? Grafana and Prometheus to track your system metrics. And for example, if you have to take the model live and the model is now taking predictions, and like you need to understand what is the latency of the model, how is the model, how much requests are coming in for you, what is the system memory, what is the CPU it is taking in. So you need to have that holistic mindset of life cycle, the performance of the model. So Grafana and Prometheus would be really helpful to understand that phase. And AI observability is another whole landscape where you do a lot of model testing with a mindset of understanding the, for example, you can check the model for drift, for how is my model behaving like 15 days ago, 30 days ago? How is this? Is there any change in the inputs that I am seeing it through for my model, or is there a change in what is the model performance? Is there any model behaving weirdly, or like keeping tab on model performance itself? So there is a difference between the system health performance and model performance. That is where Grafana and Prometheus help you to understand the ML system performance. AI observability is more about model performance, right? So, and also how different inputs and parameters are like helping the model to make predictions, um, model interpretability, sharp values, and things like that all come into AI observability. Yeah, this is the whole roadmap. But like you start at Python, and at crux you start at Python, learn ML tools and frameworks, get comfortable with CI/CD pipelines, understand Dockerization, understand the concepts of cloud, how you can take a model on the cloud and monitor it, right? This is the crux of it. And I'll share a few more resources. Um, Jupyter notebooks. You should get your hands dirty using this. Really, really important. Get comfortable using NumPy, pandas, play around with it. How do you manage your data, follow data, I would say. Matplotlib, you visualize your data. For example, in Jupyter Notebooks, you can take any simple Kaggle data set and write a script to download the data, write a script to do exploratory data analysis, like understand what's my data is, right? Understand, I know many of the this is all the data science work, but at least machine learning engineering also should know these concepts to you should know what how your model is performing, so you should be comfortable doing data profiling and things like that. So but I would say this is a start, right? This is a stepping stone. For example, are there any null values in my data? How do I clean my data? How do I do the data processing? How do I visualize my data, like model inputs and outputs? So Matplotlib is a very, very good resource to do that. There are tons and tons of Jupyter notebooks on Google to play around with. I highly, highly recommend those Jupyter notebooks one can use to just at least like reading through will help you what is going on. Yeah, highly encourage Jupyter notebooks. And have fun with data sets, like just said. Try playing around with, for example, text data sets, image data sets. I know video is a stretch for anyone getting in, but text and images are like, super comfortable. And there are a lot of like, also like, the formats, right? For example, you have data sets in JSON format, data sets in just text-based files, CSV files, and data sets in packet files, like things like that. So just explore, start with small and see if you can build a small. And also data sets these days are also coming through APIs. Just now you don't have to go on Kaggle, but Kaggle is like very good resource to for starting with, like, getting comfortable. I know many of us are comfortable using CSV files, JSON files, text files. So start with Kaggle and then transition into API data sets, right, where you can do real-time data processing. There are weather APIs, for example, where you can build a small application to understand the weather forecasting and things like that. That's a stretch goal. You start small and always build to the next step in every step. So yeah, and I can't stress this enough. I build your AI and ML vocabulary, non-technical, technical background, because I see that, at least in my experience, ML engineers interact with product people, ML engineers interact with data science to build their models. With products, they interact with how to integrate the models, and also the same with development teams to create client libraries for the model to be able to make from a simple at the end of the day, model is an object. There should be an integration inference pipelines to for the model to go live, right? So ML engineers interact with all these different orgs. So I think it's really important to speak everyone's language, and also trim down the vocabulary a little bit. And there are tons and tons of language. For example, um, inference pipeline, model regression pipeline, I'm sorry, model building pipeline. What is a pipeline? And what is drifting? What is model optimization? What is model fine tuning? There are tons of landscapes, but I think ML engineers should be able to speak everyone's language, and it is really important for the success in their career. So let's say if I'm too technical, I will not be able to talk to product people. And with data science, I should be able to communicate the language, how the model building happens, right? With development teams, I should be able to communicate what are these models inputs and outputs, how do you create APIs for the model to go live. So different genres here. Yeah, build your AI and ML vocabulary. There is no easy way. Yeah, it's really important for anyone to succeed. And don't just watch all the tutorials, get comfortable around coding and break things. Yeah, that's how you learn. um, for example, I'll share some of the insights into how I have done this um, in a moment. Um, I learned Python initially when I started working on data science applications because the models are built on Python. So I wanted to use the same language to test my models too. So I learned PyTest initially, and I tried to bring my automation knowledge into testing applications. So I have built unit and integration into models. I know developers are so busy, model data scientists are so busy that in testing is something it's always left behind. So I took that as an opportunity, and I brought my automation knowledge and start building writing tests for all these models, and that gave me a very good leverage to understand the behavior of the models, right? And I got an opportunity to also build model observability frameworks. When I say that, it means that building model measurement strategies to understand the bias of the models, whether they are working right, are there any racial biases or anything, or for example, what is the semantic similarity of the NLP based models and things like that. So I've built frameworks, and I also built hand labeling tools to establish the ground truths for the model. So yeah, all these language, like I said, should just get comfortable. There are a lot of keywords there, right? Um, and I have identified the use cases within the work that I am doing. And then I proposed how to integrate AI, and this was in 2019. I have proposed to integrate AI into the workflows to improve the application performance, and I created POCs. I did live workshops, how it can be done, and got approvals from the project managers, and I've built successfully, like integrated AI into the applications, right? And lots of networking to I think the networking helped me in a lot of ways. For example, helped me in understanding the resources. I connected with data science people to understand what they are building, so I know what to study on. For example, if they are building on text-based models, I know that text-based models are like right in front of the shop, so I don't have to wait for long. Let's say I'm studying for image model, but image based models are not there. Okay, now I have to look at text based models and understand how to test this text based models, and started working towards. So I did a lot of networking with data scientists, with ML engineers, and also project managers to get that holistic view. They helped me at every step of the way to build my skill set and also help me transition, right? Yeah, networking. Yeah. uh, and these are few more resources that I would say. I personally took foundational courses by Google, very good resources, and they also have live playgrounds to play around with ML models, build ML models. Very foundational courses. Anyone can easily do it. I did it. You can do it too, right? And if you want to build ML systems, I think a book by Chip Huon's Designing ML Systems is really good. I'm halfway through it. It's really good. I highly encourage anyone to go purchase that book and read it. And some resources that I linked are from ML Mastery, where you can find tons of resources about how do you prepare data, how do you play around with data, and things like that. And building Docker containers, resources from Docker. Um, and examples on Vertex AI notebooks from Google. I've personally used them for my pet projects to understand how different models work and how to set up different models. And yeah, highly encourage and take advantage of these free resources by Google. And I've linked a case study of Netflix. I know we all love binging on Netflix, so I just wanted to share that case study here, where how they improved their streaming quality at Netflix using ML. They covered like good information on use cases around how to um, even like, for example, you're watching and how do you predict that your internet is going to go down in next few seconds or couple of minutes, and then how you automatically decrease the playback speed, and like, different things, right? So it's an interesting read. If anyone is interested, please feel free to check them out, and I'm happy to share these slides at the end of the presentation. And can me on LinkedIn. Feel free to ask me any questions that you have. I'll be happy to answer. And I also do um, love to talk to people, different careers, and help them grow. Yeah, and thank you. And I'll take any questions if you all have. Thank you.